Hey guys, so welcome back. In the previous video, I told you all about what happens under the hood when you create and deploy a Solidity smart contract. So today we are actually going to start a mini project. Alright, so before heading on to our major big project, which will consist of a fully functioning front end, so we will actually create a mini project, alright, in which we will create a kind of simpler contract than we would actually create for a major application. Alright, and it would consist of some simple and beginner friendly functionality. Alright, and we would obviously attach this smart contract to a very minimalistic front end so that before starting the major project, you guys actually know what you are doing. So in today's video, we are actually going to go through the smart contract that we are going to be creating for this mini project. All right. So now, what is this mini project or what is this application, the mini application? What is this mini application going to do? All right. So this mini application is basically a lottery system. All right. So in which people can actually come in, all right, pay some money, let's say 1 ether, 2 ether to participate in the lottery. All right. And then we will create a lottery pool that will include the amount provided by all the players. All right. And then after some time, when the owner of the contract wants to choose a winner, he would just simply click a button and a random winner from all the participants would be selected, and all the money from the lottery pool would get transferred to his account. So let's get into the contract and how we are actually going to build an application over it. So obviously, as described earlier, we are going to define the license, we are going to define the Solidity version that we are using, and then we are going to create a contract, and this contract is going to be lottery. All right, and it would have some global variables. So the first global variable would actually be a address type. All right, so there is an actual type address inside of Solidity. All right, so this will store the address of the creator of the contract. All right, so that's why address public manager, and obviously now you guys are familiar with the access specifier public. So the manager variable would actually store the address of our contract creator or the one who deployed the contract. All right, then we would have an array of addresses. All right, so this is how you define an array. So you first write the type of array that you want, then you define it by 2 square brackets. All right, so it means that this would be an array of addresses. All right, and this would also be public, and the variable name is going to be player. So this will store all the addresses of the players, all right, the guys who want to participate in the lottery. And then we are going to create a constructor for this contract. All right, so this constructor would actually initialize the manager variable. All right, and then we would initialize this manager variable as message.sender, that is msg.sender. All right, now what is this msg? All right, so in Solidity, there are actually some special kind of variables. All right, so we call them as global variables. So if we talk about this specific MSG variable, it holds everything about the blockchain in its properties. All right, so it will also consist of the transaction object that is currently created when you click on the button. All right, so what happens is that when you actually deploy the contract, you need to define the parameters of the constructor. All right, but obviously this constructor doesn't have any parameters. This is just simply going to initialize our manager variable. So once you hit deploy, a new transaction object is going to get created with the sender's address. All right, the one who is actually creating the contract. All right, and that transaction object is actually included inside this MSG variable because it stores everything related to the blockchain. So once that transaction object is created, you can actually access it inside the Solidity script itself. So you can actually call various properties of this MSG global variable. All right, so one of these properties is actually message.sender, all right, which grabs the sender's address from the transaction object that was created while deployment. So msg.sender basically stands for the address of the person who is actually deploying the contract. All right, so once you hit the deploy button, your address is going to get taken, stored inside the transaction object, and you are basically accessing that transaction object in here, because that transaction object is also stored inside the message variable. So now let's talk about how one can participate inside a lottery. All right, so we are actually going to create a new function enter, whose whole purpose is going to make people participate in a lottery. All right, So the thing is that we would define this function as public because obviously we want everybody to access this function because we want any and everybody to participate in our lottery. All right. So this would be visible to everyone on the blockchain. All right. And we would also define this as payable. All right. Now the functions defined as payable are the functions that actually are performing some transactions with cryptocurrencies. So the thing is that payable is not defined for gas fees. All right. It's actually defined for the actual cryptocurrency transaction. All right. So the thing is that let's say you call the enter function. Obviously you would be performing some operation on the blockchain. So you would pay gas. But if this is a particular function that is only performing some operations on the blockchain and not transferring cryptocurrency, you are not required to define it as payable. All right. But let's say you want to transfer 2 ether from one account to another account. All right. So you are transacting 2 ether and obviously performing some operations on the blockchain. So the thing is that you would not only pay 2 ether because you want to pay 2 ether, but you would also pay the gas fees. All right. So the thing is that when you actually transact some cryptocurrency, in this case 2 ether, so you would need to add a payable to this function while describing it. All right. Because you are actually transacting some cryptocurrency. All right. So the thing is that now we would use a Solidity require statement. All right. Now what are require statements? Now the thing is that the require statement actually takes in a condition. All right. Now if this condition is true, this function will execute. And if this condition is false, then the function would simply return from here and return an error onto the console. So in our case, we are checking that if message.value, that is when you click the enter button and create obviously a new transaction object that gets stored inside the message global variable. So once you access the value, that is how much value you passed in here. All right. So when you actually enter a value in here in the remix value input field. All right. So once you specify the value, this actually gets stored inside the message variable. All right. And you can access it in here by message.value. All right. So we are actually going to check if this value is greater than 0.001 ether. So if anyone who is paying less than 0.001, we don't want him to participate in a lottery because that value is simply so much lower. But on the other hand, if he pays an amount greater than 0.001 in order to enter the campaign, we would allow him to enter the campaign. So you can actually define the amount of cryptocurrency inside the Solidity smart contract by just simply writing the number of cryptocurrency and writing the type of cryptocurrency. All right. So in our case, this is going to be 0.001 ether. All right. So if the message.value is simply greater than that, we would allow the person to participate in a lottery. And if it is lower than that, then we would simply return a message that the amount is too low and you cannot participate in the lottery. Now this message that I'm talking about is actually going to be handled in the front end. All right. So we don't need to add anything in here because we want to keep the operations inside the Solidity smart contract as minimum as possible. All right. Because we don't want our users to pay unnecessary gas fees. All right. Because if they are simply paying for something that is just getting displayed on their screen, I mean, that's simply unrealistic. And obviously, once this requirement is completed, that means you are allowed to participate in a lottery. We would simply add the sender's address to our array that we just created above. So we would simply write here players.push message.sender. Now you don't need to confuse this message.sender with this message.sender. All right. So this will always change. All right. So the message.sender is the current caller. All right. So the one who just pressed the enter button currently is going to be the message.sender for this function. All right. So every time you call a new function, this message global variable is actually reset. So it won't stay as is. Once the function execution is completed, this message variable simply gets dumped. All right. And once a new function gets called, this message global variable comes into life and a new message variable is created for that specific function call itself. So let's say you want to deploy the contract with your address and you hit deploy. So this message.sender would actually contain your address. Now let's say this enter variable is actually public, so it is available for anyone to access. So let's say a third party comes to your contract and hits this enter button. So for him, a new message global variable will be created for this specific function call. And if this requirement is fulfilled, so his specific message address, that is his address would be added inside the player's array. Alright, so this is very important thing to distinguish between the two message variables. Alright, so these aren't the same, these change every time for every particular function call. Then we will create a function called random, which when called will just generate a random number. Alright, so we want this to pick a random winner for ourselves. Alright, so the thing is that there isn't any predefined function in the Solidity script that just provides you a random number. Alright, so this is basically generating a pseudo random number. Alright, so how are we going to generate a random number inside of a Solidity script? Alright, so the first thing that we are going to do is that we are going to take some parameters that no one has control over. So for ourselves, we are actually going to take three parameters. Alright, the first one is going to be block.difficulty. The second one is actually going to be block.timestamp, and the third one is actually going to be players. Now players, actually someone could actually possibly have control over players. Alright, so like they could have a community and they could actually tell some people that only 5 of you participate, and once you get the winnings we would just divide it between ourselves. Alright, but on the other hand, the block.difficulty and the block.timestamp, well, these two are parameters which no one has control over. Alright, now you must be wondering, what is this block? Well, block is also a global variable that is actually created for this particular function call. Now this is the variable of the block in which the current transaction would get created. Alright, so it would have a particular difficulty and it would have a particular timestamp. Now if you look closely to this line, I'm actually getting a warning. Alright, so the thing is that after the Ethereum merge, this block.difficulty was changed. So if we look at the warning itself, it actually tells us that since VM version Paris, difficulty was replaced by prev_random, which now returns a random number based on the beacon chain. So this prev_random actually provides us with the randomness beacon provided by the beacon chain. Alright, now you must be wondering what a beacon chain is. Well, a beacon chain is actually assigned to a blockchain in order to create some randomness. Alright, in order to prevent some specific attacks on the blockchain. So a randomness is added to a blockchain which is defined by the beacon chain. Alright, so it returns a randomness beacon. Alright, so actually this block.difficulty was recently replaced with block.prev_random. So in our case also, we would just replace this block.difficulty with block.prev_random. And now as you can see, the warning is gone. But the thing is that we are actually currently also seeing a warning. But this is just a warning saying that the current VM version that we are on, that is the VM merge, prev_random is actually not supported on this and actually simply will be treated as difficulty. Alright, and we don't have a problem with that. But the thing is that if somebody is using another VM version, for it, prev_random will actually work and difficulty will not. Alright, so this will actually solve our issue for every other VM out there. Alright, now what we want to do is that we want to generate a random number. Alright, for this, we are actually going to pass these three variables inside our kchac256. Now this is the hash generator inside of Solidity. Alright. So this will basically generate a hash for any byte encoded data that you provide. Now the thing is that it's actually going to take some bytes as data, and block.timestamp, players and prev_random aren't actually byte encoded. So we are actually going to encode them inside abi.encode_packed. So this will actually encode these three variables in bytes. Alright, and then pass it inside our hash generator. And this will generate a random hash for us. Alright, and we want this random hash in integer. So we are actually going to convert it in uint256. Now, integers are actually defined inside Solidity as uint256. Alright, 256 stands for the number of bytes that you can store inside this variable. And uint is simply the replacement for integer inside Solidity. So we are actually taking three variables that we have no control over except players. I mean, some people could have control over that. And we are encoding them in bytes, passing them into a hash function, generating a random hash, converting that into an integer and simply returning it. So this is kind of a pseudo random number generator. Alright, so this will actually return a random number when you call it. Now, before getting into the function picked winner, let's just talk about this getPlayer functions, cause it's just simply returning our players array. Alright, so the function getPlayers is actually just basically public view, and it would return an array of addresses, and we wanted to just store it in memory just for this particular function call. and we would just simply return players. Alright, and this will return the full array of addresses of all the players that have currently participated in our lottery. Now, about the function picked winner. So when this function is called, this function will actually generate a random winner for ourselves. Alright, so the thing is that this function is going to be public and it's going to be restricted. Alright, now what is this restricted? So there are something called function modifiers inside of Solidity. So as you can see down below, I have actually created a modifier called restricted. Alright, now you don't need to name it restricted, you can name it anything that you want. Alright, you can name it ABC, you can name it your name, you can name it possibly anything that you can think of. And what I have done inside this modifier is that simply added a require statement that message.sender should be manager. So what this means is that once I call a function and a transaction object is generated, so the address of the function caller inside that transaction object should equal the manager. That is the one who actually deployed this contract. And then as you can see in the next line, I have simply written underscore and semicolon. Alright, so this is something that is modifier specific. Alright, so modifiers are actually added to functions as you can see above here. Alright, so what this modifier does is that this adds a require statement to this whole function itself. Alright, and this underscore basically means that first run this require statement and after that run the whole function that's attached to this modifier. So creating modifiers actually adds some code simplicity. Alright, so you could have different modifiers for different require statements and attach them to different functions. Alright, I mean here I could have just simply added this require statement inside this function, but I did not because I wanted to introduce function modifiers to you guys. Alright, so we have created a function modifier restricted, we have added a require statement and we have attached it to a function pick winner. Alright, so if this require statement is false, so this function pick winner would simply be returned without getting called and it would just simply display an error message onto your console. Now let's move on to the pick winner function itself. So we are actually going to select a random index from the array of players. Alright, and this number is actually going to come from the random function that we just created. Alright, so we are actually going to call our random function, which is actually going to generate a huge random number. And then we are going to get the remainder by dividing it by players.length. So this will give us a random index, which we can access inside our players array, which will give us a random winner. And then we are actually going to write our first line that is actually going to transact some value. So we are going to access the random index that was generated inside the players array. So we are going to access it by saying players and then passing the index. And then we are just going to simply say dot transfer. Alright, so every address has some functions also attached to it. Alright, so when we are accessing a random address inside the players array, so it has a transfer function. So we are just chaining a transfer function on an address. So this is address dot transfer. So this is the winner address dot transfer. And then we are going to transfer the whole balance that is inside the contract. Alright. So as you know, once you deploy a contract also has the address of itself and it also has a wallet of itself. Alright, so it can actually store cryptocurrency at its own address. So we access the address of this wallet by just saying address this. This refers to the instance of this contract. Alright, so we are just going to convert this into an address type, which will give the address of this contract. And then we are going to access the balance of the contract. Alright, so address.balance, that is address of the contract.balance. So all the amount that is inside of our contract, we want it to get transferred to this winner address. And this whole thing is going to be payable. So we are actually going to convert it into a payable type. Yes, payable is also a type inside Solidity. Alright, you can actually define variables as payable for the variables that are actually going to do some transactions. Now the final thing that we want to do is that clear out our players array once a winner is selected. Alright, so we would just simply say players is equals to new address array and the length would be 0. Alright, so we are just simply defining players as a new array of addresses with length of 0. So this summarizes the whole lottery contract that we are going to create for this mini project. Alright. Now, in the next video, we are actually going to deploy it onto the Sepolia test network and then create a minimalistic front end in order to interact with this contract on the blockchain. All right. So I'll see you in the next one. And until then, keep chilling at the CodeCove.